Hello, we are the Data Science for Social Good Fellows, and we are in partnership with Mentor Canada. We'll begin with a quick round of introductions before we get started.
Hi, I'm Maxine. I just recently graduated with my Bachelor of Science in Cognitive Systems with a minor in Data Science.
Hi, I'm Isabel. I'm completing my Bachelor in Science in Statistics with a minor in Math.
Hi, my name is Vincy, and I'm a senior psychology student with a minor in data science.
As part of the DSSG program, we use data science to approach real-world social problems. Our partner, Mentor Canada, is a national nonprofit organization dedicated to expanding access to quality mentorship. Together, our shared goal is to analyze how youth mentorship affects subsequent life outcomes, and we aim to help Mentor Canada build a strong case for grant applications, expanding high-quality and accessible mentoring across Canada. Over this summer, our team worked closely with Mentor Canada to explore how mentorship shapes long-term life outcomes for youth, especially those from underserved community. Now, let's quickly walk through the data description. Our dataset comes from a national survey of 2,838 respondents between ages 18 and 30. It covers several life outcome variables like income, education, and mental health. Crucially, it also includes retrospective data, such as youth socioeconomic status, abbreviated as SES, whether participants had mentors during childhood, the quality of those mentors, and what access barriers they faced, for example, being put on waitlist. The data gives us a unique lens to examine the long-term impact of mentorship. To ensure reliable insights, we cleaned and standardized the data, as well as checked for structural missingness. In addition, we connect analyses using both the unimputed and imputed datasets, performing survival analysis across different imputations, including other robustness analysis. For the sake of time, today's presentation will focus on results on the unimputed data. We focus on youth who had at least one mentor growing up for statistical modeling. We also use clustering methods like latent class analysis to uncover further insights. Lastly, we applied natural language processing to process published reports from Mentor Canada to better understand barriers and needs across youth populations. Now, with this brief overview of the data, let us dive into the results by first introducing Maya.
So, this is Maya, a hypothetical persona. She's 15, lives in Ontario, and in a low-income household within an Indigenous community. Her school has limited support, and her family is stretched thin. She wants to graduate high school and get a job or pursue more education. Maya feels overwhelmed because the path feels uncertain to her. But what if Maya had a mentor, someone to guide, encourage, and open doors? Let's look at what our data can inform us for youth like Maya. In our data, mentorship boosts high school graduation rate and employability. Among low SES youth, those with mentor reported 10% significantly higher high school graduation rate. And for high SES youth, the gain was smaller, only 3.5%. This shows that mentorship has a greater positive impact on high school graduation rates for low SES youth, which is someone just like Maya. Mentorship also boosts workforce and training participation as well. Low SES youth without mentor were 36% less likely to participate in workforce or training program. And critically, we identified significantly more Indigenous youth grew up in a low SES household compared to non-Indigenous youth by a difference of 30%. And given the benefits of mentorship on graduation and employment, these results make a case for directing greater resources towards mentorship programs to bridge socioeconomic disparities for low SES children, especially for Indigenous youth. Mentorship can also help with Maya's further education. Compared to high SES youth without mentor, low SES youth without mentor experience 62% reduced odds of further education. But low SES youth with mentor experience only 10% less odds of pursuing post-secondary education. And there is in fact a significant interaction such that mentorship helps low SES youth more than high SES youth. Within low SES, those who had a mentor had 2.3 times the odds of entering further education than other low SES youth who had no mentor. And within high SES, mentorship increased further education by only 1.4 times the odds. Beyond education and employability, mentorship also seems to impact future earnings. Among youth without mentors, there's a $13,600 median income gap in adulthood between high and low SES background individuals. But among those with mentors, the gap shrinks to $72,000. This suggests that mentorship nearly halves the income disparities tied to socioeconomic background, which is a 47% reduction. However, we do need to be careful with this interpretation because this income gap reduction may be due to those who grew up in high SES but needed mentorship tend to be lower earners in the future. But what about personal well-being? Of course, education and employment are important, but does early mentorship augment mental health later in life? And the answer seems to be yes. Youth who had a mentor between ages 6 to 18 reported better mental health, averaging 0.19 points higher on a 5-point Likert scale, a small but significant effect. And interestingly, we see that SES alone didn't affect mental health, which suggests that early mentorship alone may be beneficial for long-term mental health support. And mentor types also seem to matter. Youth who received formal mentorship, like structured mentor programs, had 2.6 times higher the odds of reporting good mental health. And youth who received spiritual, religious, cultural support from their mentor were 16.4% more likely to report good mental health. And in short, access and support to mentorship are crucial. And for Maya, the difference can be life-changing. But there is disparities in mentorship, such that barriers to mentor access are unequally felt. A significant greater proportion of low SES youth reported unmet mentoring needs compared to high SES youth. And compared to high SES youth, 10% more low SES adolescents were waitlisted to receive mentorship. And 6% more low SES youth felt the available programs were not useful for their own life. And 6.4% more low SES youth felt pure stigma around getting a mentor. And yet, low SES youth were more likely to see mentorship as more valuable. This suggests that low SES adolescents sees the values in mentorship, but they're unable to acquire adequate mentorship due to the aforementioned barriers. So let's go back to Maya. With the help of mentorship, Maya now is more likely to graduate, more likely to enter training or work, earns more in adulthood, and has a higher chance of thriving emotionally. And multiplying this by thousands of youth, just like Maya across Canada, one thing is clear to us: mentorship can indeed transform lives for the better.
And now we'll begin talking about our subgroup exploration methods and see how mentorship can help someone like Maya across different life outcomes. To explore hidden subgroups in the data, we applied late-in-class analysis, abbreviated as LCA. LCA is a statistical technique used to identify distinct subgroups or clusters within a population based on patterns in the data. LCA is commonly used in research to explain patterns in respondents' behaviors or characteristics by grouping them into clusters, or which we call latent classes, with similar response profiles. LCA estimates through maximum likelihood using an iterative algorithm. After testing different combinations of variables to define response profiles, we found it most effective to apply a latent class analysis to our key response variables, the same measures we use as outcomes in our regression models, which capture individual well-being and life outcomes. The indicators we included are employment status, so whether the respondent is currently employed, further education, so whether they participated in further education beyond high school, their mental health rating, overall sense of belonging, and social capital measures, including access to household help, financial support, emotional support, and career advice. After comparing model fit statistics for 2 to 6 class models, we found that 3 classes fit the data the best. And now we will examine our 3 learning classes. Class 1 accounts for 46% of respondents and represents the highest performing group, with high rates of employment and further education, strong mental health ratings, a strong sense of belonging, and a robust social capital. And we have Class 2, which accounts for 19% of respondents and falls in the middle. This group has high levels of further education and employment, moderate mental health ratings, a weaker sense of belonging, and a neutral social capital. And we also have Class 3, which makes up 34% of respondents and is the lowest performing group. Despite high employment rates, they show lower rates of further education, weaker mental health ratings, a low sense of belonging, and a limited social capital. We examined how having a mentor between ages 6 to 18 relates to these groupings and class assignments through the use of a multi-class classification model. We found very significant results. We found that youth with a mentor were 25% less likely to fall into the lowest performing group compared to the highest performing group, and that youth with a mentor were 45% less likely to be in the moderately performing group compared to the highest performing group. We've included a graph to illustrate these results. In conclusion, these results convey that mentorship is strongly associated with better life outcomes. For example, although our analyses show Maya is more likely to fall within one of the lower performing groups, our results show that with mentorship, Maya has a higher chance of falling within one of the highest performing groups. Overall, we found that youth who have a mentor are significantly more likely to belong to the highest performing group.
During our time here also at DSSG, we also explored NLP applications, specifically the implementation of a RAG system. We wanted to address this common problem of a lack of accessibility to reliable resources. This affects policymakers, advocates, youth like Maya, and especially grant writers. In the early stages of a grant application, a lot of time is spent on needs assessment and background research. This can include finding credible data, reviewing studies, and framing the context for funding. During this process, going through hundreds of documents can be demanding for organizations, especially those with limited research support. To address this, we developed a solution that streamlines the research stage in the grant writing process. We created a RAG chatbot that uses our database of Mentor Canada resources and generates a nuanced response complete with source citations. By lowering this barrier to trustworthy information, we can make this process more efficient and inclusive, enabling equitable participation in research, advocacy, and decision-making. Here you can see that we've asked our chatbot, how can a mentor benefit a youth from a lower socioeconomic background, in which it produces a response with specific references to the literature. In this example, our RAG pipeline touches on how mentorship can help low SES youth build confidence, expose youth to new opportunities like education or career paths, provide emotional support, and help them navigate systemic barriers, which are all findings consistent with the significant results from our statistical analyses. But before we continue, let's first remind ourselves what natural language processing, or NLP, is. NLP is a field of AI that allows computers to interpret, generate, and understand human language. In the context of mentorship, NLP can help us parse through resources to identify common themes and barriers, which can ultimately better inform mentorship initiatives. Furthermore, what do we mean when we say retrieval augmented generation, or RAG? RAG is a technique that can be applied to LLMs to improve its reliability and accuracy by retrieving information from an external knowledge store. In other words, instead of relying only on the original data that the LLM was originally trained on, RAG actively seeks to pull relevant information from the database that we populated. Using RAG allows us to generate responses informed by the literature, ensuring accuracy for grant writers and practical relevance for individuals like Maya. In the interest of time, we just have a brief overview of the RAG's prototype components. So first we began with raw PDFs sourced from Mentor Canada, in which we applied optical character recognition and text pre-processing to extract the content. The text was then chunked using a recursive character text splitter and embedded using MixSpread's large embedding model into a pinecone vector space. At query time, the system uses cosine similarity to compare our document or the query to our document embeddings and retrieves the most semantically relevant chunks. These chunks are then passed to the Mistral large language model, which generates the response. So for our RAG pipeline, we weren't able to use traditional evaluation methods due to time constraints and resources. And as a result, we weren't able to create a data set with ground truths that reflected domain expertise. But instead, we turned to a hybrid evaluation approach using the LLM as a judge strategy, which uses a large language model to evaluate responses based on a rubric with specific criteria. This gave us a way to evaluate our prototype efficiently without relying on time-intensive human review. So we created a small data set of 30 questions and converted each question into a JSON object that we passed through our evaluation pipelines in batches of 6. So as you can see here, our JSON objects consist of a user input, so a question, the retrieved context, and the response. So to clarify, when we made our evaluation set, we started with 5 questions provided to us by our project partner, and we used ChatGPT to generate 26 more in a similar style. So for example, when we gave ChatGPT the question, what are the benefits of mentoring? It was able to give us these 4 similar questions, which we could use as a proxy for realistic queries, helping us build a bigger, more diverse data set. So during evaluation, we were interested in the metrics of faithfulness and answer relevancy. So faithfulness measures how factually consistent a response is with the retrieved context. So basically, it just checks whether the answer is grounded in the provided sources without adding any unsupported information. And answer relevancy measures how well the response addresses the user's questions. We selected these metrics because at this stage, we just wanted to quickly verify that our system was able to return useful answers with minimal hallucinations before we invested and explored more complex evaluation methods. With this evaluation, we achieved an average faithfulness score of 0.95, indicating that our generated answers were typically consistent with the retrieved context and contained minimal hallucinated information like we had hoped. However, our average answer relevancy score was lower at 0.86, suggesting that our response generation did not always fully address the question. We wanted to better understand why the average answer relevancy score was lower, so we took a closer look at some individual examples. So for example, what are some successful models of community-based mentoring scored perfectly for faithfulness, but scored 0 for an answer relevancy? In the sample, the retrieved context outlined different mentoring settings and some mention of community-based mentoring, but did not seem to name specific models such as Boys and Girls Club or Big Brothers, resulting in a faithful yet only partially relevant answer. Because of this, we began to speculate that maybe the generated questions weren't addressed by our current knowledge space. While the ChatGPT generated questions helped us quickly simulate real-world queries, this was a much more naive approach. We weren't really sure if these questions were actually addressed by the corpus, since they weren't drawn for the documents themselves. This led us to consider different ways to create more accurate proxies when we didn't have ground truth data available. And to make our evaluation set a bit more representative, we plan to take a second, more grounded approach in the future. So we plan to use regular expressions to scan the processed PDFs for any lines ending in a question mark, allowing us to extract questions that already exist in the documents. And then after extracting these, we would probably manually review the results to keep only the well-formed questions for model evaluation. We hope that the result is an evaluation set that can better capture how the content was meant to be used and what real users might ask.
Each of us focused on different parts of the project: statistical analyses, model development, and clustering methods. To unite everything in one place, we built a resource hub, a website where we share our headline results, including findings for lower SES youth. As well, we included transparent documentation of the LCA and other methods. We also added an interactive RAG assistant that lets stakeholders ask questions and instantly pull evidence and citations. By packaging the work this way, we aim to streamline grant writing, support data-informed decision, and make the benefits of mentoring clear and accessible to the public.
As for limitations, our analyses are Our analyses are based on survey questions and data that show correlation, not causation. Other factors like who chooses to seek mentors, so self-selection bias, or other systemic differences in access to opportunity might also explain our statistical results. More experimental research is required to confirm this. Furthermore, our analysis is also based entirely on responses from the Mentor Candidate survey that we were provided. This means that we were limited to the questions that were actually asked in that survey, and not all of the potentially relevant variables were included. So there may be other important factors that influence our findings that we weren't able to capture. And as a result, while our results are informative, they may not reflect the full picture. And while we were able to produce a working minimum viable product, or MVP, for our RAG pipeline, relying solely on open source tools constrained the level of performance we could achieve compared to using more advanced proprietary solutions. In addition, not having access to an evaluation set with established ground truths meant that we had to rely on proxy methods to assess the model's accuracy, which ultimately limited the precision of our evaluation.
Potential next steps for a project could include applying cross-validation or bootstrapping techniques to ensure the fit and stability of our latent models. We could also expand and update the website with the full range of our statistical findings and analyses and deploy it to GitHub pages so that stakeholders can easily access the information. As for the RAG, improvement is an iterative process. That requires us to consider enhancements, especially in the steps relating to the knowledge store and generation steps. Furthermore, conducting a literature review of peer-reviewed research on mentorship would strengthen the credibility of responses and expand the breadth of knowledge beyond our current knowledge store.
And altogether, our project effort addressed 4 chief goals to pursue the broader social good. First, we uncovered marginalized groups who benefit the most from mentoring. Then, our statistics and data science results can serve a strong foundation for our project partners' grant proposals. And through those grants, mentoring can be expanded and become more accessible across Canada, especially for marginalized, low socioeconomic status groups. And finally, the impact of our results can be cashed out in helping youth like Maya succeed and grow through meaningful mentoring program. And this wraps up our final presentation. Thank you so much for listening.